I've been making steady progress on the main board in this Predicta Holiday set. I've replaced a bunch of the capacitors, cleaned off the board, replaced the busted 7-pin sockets. And now I'm taking a little break from that to work on making a replica for one of these networks, in particular this guy, the vertical integrator. That's the one here on the schematic with that goofy looking symbol where it's a long squiggle on the line, 90K and 0.004. That's essentially a capacitor wrapped around a resistor. Imagine like a metal tube slid over a resistor. Well, that forms an integrator. In a more traditional way, you'd see that in a set. 2 resistors, 3 capacitors. So when it comes time to replace that, that's typically what people do. And the important thing is to match the time constant. So if you multiply 90 by 4, you get 360. So a couple possible ways to do it are to use 39K resistors and 3 1500 picofarad caps. That gets you about 351 time constant. Or in this case, I had some capacitors left over from another project. I had 2 1200s and a 1600, and I used 43K resistors, which gets you pretty darn close to 360. But what I wanted to talk about was not so much that. Here's the schematic for that whole integrator. But I want to talk about how to actually construct them. In the past, I showed you guys I used perf board, and I mounted the components on here and thread the leads through, and then would solder them on the back side, and then cut out a little little square of this, and then encapsulate it in epoxy and mount it on the board, which works fine. But I'm running low on perf board, and it's a little tedious. So I was thinking, well, why not just make it in free space? So that's what I did. So no perf board at all, just the parts. Another way you might want to do it is, instead of using perf board, just use a piece of unclad copper board, or clad on one side. I guess you could use that for a ground plane, and use like a dead bug construction technique, where maybe use a little hot glue or something and stick the components down, and then wire them up. But this worked out quite well. It's just about exactly the same dimensions as the original. So what I'll do with this is I'll try to encapsulate this in epoxy with no backing. I'll probably just smear a little and let that harden, and then put on the rest. Because if I try to do it all in one shot, it's just going to drip. It's going to flow right off this and make a big mess. So it'll be interesting to see how that goes. And I'll mount it right in there, and I'll do the same thing for the others. Here's another status update. Finished recapping and replacing the resistors on the board. I just temporarily have it fitted on here to see how it will go. And I've got 4 of the 5 networks done. And all epoxied up. After I did this guy, I ran out of that type of epoxy and I switched to this stuff. In fact, I didn't have a choice. That's all they had in the Loctite brand was the gel type. Well, it turns out it actually is easier to use because this stuff is really viscous right after you mix it. Whereas with the 5-minute clear stuff, I was mixing it and having to wait a few minutes for it to start to set up, and even then I had to keep kind of moving the part around as the epoxy would start to dribble off on one side or the other. This stuff, pretty much once you slather it on, it doesn't move. It's slightly opaque, but that's no big deal. Might put a little more on this guy just to kind of fill in the voids a little bit, but otherwise these are good to go. Here's a better look at the board. See, it has a nice warp to it. Probably from heat, or just when somebody worked on this and put it back down, they didn't have it set in properly. I notice when I put it down now, if I push it down and solder all the stakes in place, it flattens the board out. Replaced all the 9-pin sockets. Now, something else I've been curious about is this guy, which is the buzz control for the quadrature sound detector. Curious in terms of what's actually in here, because sometimes they look pretty grungy, pretty nasty. And I was thinking if that's just a plain old exposed carbon type trimmer potentiometer, that could be a source of noise or trouble. Well, I happen to have a board that I scrapped out, and I took the part out so I could see what was inside. It's actually wire wound, and looks quite nice inside. So even though they look more like grungy and horrible on the outside, I think they're just fine, and no reason to be concerned about them. Also, no need to shoot contact cleaner in there, I wouldn't think. It's not like a carbon type that'll get gunked up. Although I suppose the wire maybe could. I don't know. Alright, so back to this. I cleaned all the solder off of these things where the stakes attach. Cleaned pretty much all the goo off the wires in this area, which were really sticky. Whatever type of plastic they used on these, with time, heat, whatever, they get really sticky and dust attracts to them. It doesn't harm them, it's just nasty to work on them because you get that sticky goo on your fingers when you're working on the wires. Like here's some that are still nasty. See, now my fingers are all sticky and gross. So I just used denatured alcohol to clean them off. I've tried many different solvents, and so far that one works the best. The nice thing about denatured alcohol too is, well, it's basically booze. It's grain alcohol with some stuff added to it so you can't drink it without getting seriously ill. Well, it doesn't have much odor. It's not like using lacquer thinner or acetone or anything, so you won't start choking on fumes in your workshop when you work with this stuff. Alright, so I had one more network to build, and I couldn't because I ran out of one key component, which was one of those little blue capacitors. What the exact value was. One of the larger ones. 4700 or no 8,000, the 0.008, 8,000. I might have found exactly 8,000 or with 8,200. I don't remember, but we'll find out in a second because my order just arrived, along with a bunch of other stuff. Because I also was running short on some of the electrolytic capacitors I'm going to need too, so I ordered up a bunch of stuff. So what all's in this box? Well, some electrolytics. As I said, I'll need these underneath the chassis for the power supply. And here's a couple of those blue caps, 8200 picofarad. Need one of these to finish that last network. And there's a few parts in here for a couple upcoming Admiral TV chassis that I want to restore. But most what's in this box are these brownish looking resistors. Hundreds of them. Well, I did a video a while ago called Capacitor Talk where I talked about various types of caps available and why you might want to use each type. I will do the same for resistors and explain why I just bought a box full of these brown resistors. Alright, the board is completely done. The networks are done. I will install the networks, install the board, flip this thing over and start working underneath the chassis. I'm just about done rewiring the board back in. As you can see, I left the replica networks unpainted. I actually kind of like this look. You can see the components inside. Kind of nifty. I guess I'll contact the guy I'm doing the work for and see what he thinks. I can easily paint them in place, no problem. Or I'll just leave them like this. I figure also, too, even if I am going to paint them, I'd like to leave them like this until the set's working. In case I made a problem, I can peer inside and see if I made any mistakes. Alright, so I've got all this side done. Now I'm getting to the area where the wires were clipped and bodged and whatnot by the guy who clipped it out and flipped it on its side. So for example, this wire was cut and spliced, and no, it's too short really. It's supposed to go over here, so what I think I'm going to have to do is trace out where it goes underneath the chassis, somewhere over here, and run a new length of yellow wire. And these others they're cut short. There's just enough wire that I can strip some of the insulation back and get around that post. The green one goes over here, and then just a few connections over here. Then we're going to flip this over and start working underneath the chassis. The first thing I want to do underneath the chassis is restore filament continuity. So, for one, the burned out filament dropper has got to go. I've already clipped it out. I'm working on replacing it with some discrete power resistors. 2, I'm going to replace the thermistor. And 3, figure out where this wire went to. Well, I've already traced it out. It goes around and around and around. It goes over to here, which then wraps around and goes to here. It's one side of the AC line. This safety cap going right across the AC line, that's got to go, be replaced with a safety rated cap. So this went to the power switch that used to be up here. And this wire that I found wrapped around the thermistor, this is the other end. So these two should go to the power switch. When I get a replacement power switch, for now I could twist them together. So the other end, one side goes to the thermistor, and the other wire goes around and around through the other side to the fusible resistor. So I am looking right here. Power switch, one side goes to 5.6 ohm fusible resistor, other side goes to that thermistor. So that mystery has been solved. So I'm going to twist these two ends together, replace that, finish wiring this up, flip this thing over, put the tubes back in, and see if I can get this to light up. Alright, got my new filament dropper resistors and my thermistor. I doubled them up because these are 221 cold and the original should be around 401 cold. And here's the replacement AC switch, wires just twisted together with some heat shrink tubing. Alright, now I gotta flip this over, put all the tubes back in, and simulate the picture tube being attached. In place of the 3AU6, I found a 3BA6, which might be a valid substitute, I'm not sure, so I just dug up a 3AU6 and installed it. Now, I'll get it set up for continuity check. Grab my ohm meter, and I'm going to hook it up to the AC in the lock. Right here. Alright, it's showing open, which is good, actually, because I have not plugged in a substitute for the CRT filament. For that, I've rigged up a power resistor with some lugs on it. There we go, 15 ohms. It's close enough. I gotta figure out which two pins it goes in. Pretty sure to this one. So we're gonna double check. Yeah, let's see, where's the thermistor? Okay, the way I figured out which pins were the CRT filament is I remembered when I remounted this main board, there's a ceramic disc capacitor that goes from the board to the chassis ground. That is this capacitor C58, which is also the filament. They put the caps here staggered throughout the filament chain to get noise out of the filaments. So that goes to pin 4 the CRT. Well, I know which wire that is. It's this guy, and it goes right there. So that is the CRT plug. Now the other side of the CRT filament goes to the tuner. Well, this is the tuner harness over here. And the wires go around and around, and trace them out. There's a brown wire. Goes through here, and that goes right here. So these two must be the CRT filaments, and that's where I need to put in my simulated filament. So right like so. Okay, now I'll check that for continuity again. Uh, 1.6 megohms, a little on the high side. It's jumping around. I mean, something's loose somewhere. Or a tube could be burned out, of course. I haven't actually checked the tubes yet. Let's take one out and see what happens. It's curious, it goes to infinity with the tube out, but with the tube in, it's giving me in the high mega ohm range. Seems to me like it's making contact, but not very good. Alright, so I will just trace the series string out and find out where the problem is. So I got one side going to the AC lug, and I know that wire comes right over here right after the switch, so that should be about 0 ohms. Yep, 0.2. Then it goes to the thermistors, and then the filament droppers, and over here we should have around 600. Okay, good up to there. And from that, it goes to what? Goes to the main board, and then comes back out over to here. .17K seems perfectly reasonable. That's definitely mega ohms. I was just double checking that I wasn't seeing 1K before, thinking it was 1 meg. Now that's 1 meg, alright. So we are good up to here. So my first thought is that I don't have that jumper in the right place for the CRT filament. Oh, and you know what? I don't. Ah, it's tricky. That brown wire I thought was going to this lug. I thought the brown wire was going to this lug, but no, the brown goes to the center. It's green wire going over here. So I just need to reposition the power resistor. So instead of like this, it should be like this. And now, excellent, 1.2K. All right. Now, time for the real deal. Look this up to some power. Got it plugged into my PR57. Turn the lights off. And here we go. No, something's not definitely plugged in there. It's definitely plugged into PR57. Resistor's warm, okay. I don't see anything glowing. I think this is missing. Oh, there we go. Okay, this is the action of the thermistors. Just took a long time to light up. Some of those power resistors and the filament droppers starting to get toasty, just like they should. And then I'll check this pilot light under here. It's in there. I can see somebody replaced it at some point, did a crap job putting it back together. It looks burned out. Yep, it's bad. It's a Type 47, I got a bunch of those, no problem. That'll do. No, I said they did a bad job putting it together. What I mean is this part of the plastic should get up inside the cardboard. They just have this cardboard here that's being completely crushed by the spring clip. Alrighty, let's try that again. Hey, got a pile of light now. It'll probably be a bit easier for you to see from this angle. There we go. One functioning pilot light. And all the tubes are glowing. So that's fantastic. And now for the fun part, which is to finish all the recapping underneath the chassis, including the electrolytics. So I will pick up in the next segment when that is done.